All right, so we're back talking about section 1.5, your quadratic applications, and following along on your note packet that's attached. So we're to the second page now. In the first video, we looked at how to set up the rectangular box type of question. So now I want you to pause the video if you haven't already had time to look at this on page 2 and try to set this up. Draw the picture, think through it, set up an equation. But I'm going to go ahead and be doing that now. So it says in this problem that you've got a rectangular piece of metal such that it's 10 inches longer than wide. So the long is 10 more than the wide. The wide is the unknown x. The length is that plus 10 according to the wording in the first sentence. Then we're going to cut out squares from each corner. We're going to clip out these corners perfectly square such that when we fold the box sides up, it makes it an open top box. So we're clipping out and it says 2 inches all around. So 2, 2, 2, 2, and all these little squares. So the box that's formed has a volume, and we learned that volume is always the 3 dimensions multiplied together. So it tells us the volume of this box has to be 832 in cubic inches. And then we're asked to find the dimensions that would make that work. So the actual box isn't the full x plus 10 for this length. X plus 10 was the rectangle, the original piece of metal before it clipped. So now it's x plus 10, take out 2 that way, and we'll be taking off 2 that way for a total of 10 minus 2, which would just leave 6. So the length of the actual box is x plus 6, algebraically. The width of the actual box, again, it was x originally, then we clipped out 2 inches, so we could reason out that it's x minus 2 or x minus 4. Then for the height, that's how far this bends up. We're bending this side up to make a height of 2 inches. So that would be our equation we could reason out from the reading. You could FOIL all this and then distribute the 2, pull it all back together in standard form, but always try to make it easier on yourself when you can. If there's a way that you can reduce your equation, try to do that. So we can divide this by 2. Because it is a multiplier, there's nothing that stops us from just dividing both sides by 2 and cleaning it up a little bit. And the ones in your book are kind of contrived so that you can do that. If it would have been an odd number here and create a fraction, we don't want fractions. We always clear the fractions. So don't do it if it's going to make it fractions or make it harder. But if there's a way to make it easier, feel free to look at that. So now we've got to FOIL, outer, outer, inner, inner, last, last. Use your FOIL method to clean that up or multiply all that out. And then we see our quadratic. X squared is what makes this, everything in section 1.5 quadratic. As long as you have an x to the second, we're looking for 2 solutions, and we use our quadratic methods. For a quadratic equation, we always want to get everything over to one side equal to 0. So again, it can go left or right, but most of the terms were already on the right, so that seemed a little better. So that would be our quadratic equation in standard form. And then you would proceed from there to solve it. We have 4 quadratic methods. Factoring is always an option, but not everything is factorable, but it is the quickest method. If you can foresee kind of what works for it, you will get there quicker than all that formula. So I'm an algebra teacher, so I probably would default to that more likely than maybe everyone else, but I would try that. I would think through what multiplies to be 440 and then combines to be the 2 in the middle, and you can FOIL this and see it does work. But it may take you some time to figure that out and punch it on your calculator. So if you see that's driving you crazy, we're going to also look at it with the formula. Then you set each factor equal to 0. And it gives you 2 solutions of negative 22 and positive 20. Both of those are viable, both of those work algebraically, is what I want to say. They work, they're algebraic solutions, but only one is reasonable in the reading problem. So when we go back up here, we can't have a negative side. That's what we let x equal, is the width of a rectangle. Well, a negative width makes no sense. So that answer gets thrown out. And the only answer that makes sense then is the 20. And you can check it back in the original. That will be the width of this little rectangle, and then the length is 20 plus 10. Now that we know what x is, we can plug that in for x and say x plus 10. So it is a 20 by 30 original piece of metal that makes this happen. So what I want to go back to now is talking to you about the quadratic formula. I want to remind you of that here. I know you've had a little bit of time now in the semester to get your feet wet with that, and I just want to use that again if that's something that you're still maybe having a little trouble making peace with. I want to demonstrate that. If you're good with that, then you'll fast forward a little bit. But the other way to solve it, to get from here to the solution, is with the quadratic formula. Once it's in standard form, that's your A, B, C of the formula. So A is 1, B is 2, and C is the negative 440. So we also could have used the quadratic formula, negative B plus and minus the square root of B squared minus 4AC all over 2 times A. That will also give you your 2 solutions to any quadratic. So the formula says take the opposite of B, so it's negative 2 plus minus the B squared, which will be 4, minus 4 times A times C, so times the A value times the C value, plug all your values in this formula, over 2 times the A value. Then you want to simplify what's under the radical, that's called the discriminant of your quadratic equation. And it tells you if you're going to have these nice rational solutions. If so, like we're going to have here, that means it was factorable. So rational if that comes out to be a perfect square, which we should expect to see. So you can type this on your calculator, 4 minus 4 times 1 times negative 440. So type that away and let's check that out. I'm going to do so as well. Should be 1764. And 1764 just happens to be a perfect square. And when you do the square root of 1764, it comes out of the radical as 42. So negative 2 plus and minus, all that is 42 over 2. And then we really have 2 problems. Negative 2 plus 42 divided by 2, and negative 2 minus 42 divided by 2. So you can do those separately, and guess what? They're going to be these 2 answers. Negative 2 plus 42, and you can use your calculator, is 40. 40 divided by 2, that's 20. That's that answer. Negative 2 subtract 42 would be negative 44. Negative 44 divided in half would be negative 22. That's that answer. So exactly the same answer, just a different method to get there. This is a sure way to get there, and the more you practice that, the better you get with that. So I find students start working through that this time of the semester, and by the time we get to the test and along halfway through the class, you're just doing that almost in your sleep, I hope anyway, right? That it's just getting easier all the time. All right, so I hope that helped. All right, moving on, the next problem on your handout goes back to the Pythagorean theorem, and we've got Mia flying a kite. So let's say here's our Mia flying this kite. And it tells us you can set this up, so always feel free to pause the video and do this. The vertical distance from her hand is 10 foot more than the horizontal distance. So if we call this x, this is x plus 10. Assuming that the string is being held 5 foot from the ground, so we're saying like she's 5 foot tall there to her hand. Find its horizontal distance from Mia's hand and its vertical distance from the ground. Oh, it's a 50-foot string. I knew we needed one more thing. I was overlooking that. It tells us the string it's on is 50 foot. So that gives us a right triangle situation, which means we can use Pythagorean theorem. So side squared plus side squared equals hypotenuse squared. And you can see my work on that. I've got, it doesn't matter which order, which side first. So I did this side plus that side squared will equal the hypotenuse squared. And so this can be simplified out. X plus 10 squared is a binomial. Make sure you either FOIL that or use the squaring pattern. And then 50 squared will be 2,500. So when you FOIL this, just be careful. There's more to it than might seem to the eye here. X squared and 100 is definitely happening, but there's also an outer and an inner 10x, which doubles to be 20x. So when in doubt, just FOIL this to be safe on that. That first is x squared, outer 10x, inner another 10x, and last times last is 100. So there we see our quadratic equation forming for us. We've got two squared terms, 2x squared, 20 x's. Bringing this across with the 100 makes minus 2,400 equals 0. This can be simplified, like we said earlier. It's optional. You could go ahead and do A, B, and C like that, or even try to factor it like that. But notice everything is divisible by 2. So why not make it easier on ourselves? Make the numbers a little smaller by dividing every term by 2. And 0 divided by 2 is 0. And then proceed from there. And you know I'm probably going to be a factoring method person, so I would work on trying to find the combo that factors here that makes that 10x in the middle. Then set each factor equal to 0 to get our 2 solutions. Once again, one of the answers may not make sense in the real problem, real life, like a negative distance doesn't make sense, so we would throw that answer out. And we would only use the positive answer here. So 30, and 30 represents the distance right here over from Mia's hand over to the bottom of the ground before we go up. So depending on what the question asks, if it asks simply what x represented, that horizontal distance, the answer is 30. If it asks for this distance, it would be 40. If it asks how far to the ground, she's got this 5 foot from the ground, and the reading would be 45. So just interpreting what they ask you, go back and kind of read and make sure you answer what was asked in the problem to finish it up. All right, we got one more topic in section 1.5, one more type of problem that shows up in this section, one more application, and it is the height of a projectile. So on the next page, you will see that all objects propelled into space follow this neat curve called a parabola. We're really going to keep talking about this parabola as we proceed through the class. It shows up pretty much the rest of the semester. The parabola curve is like a U kind of shape. It goes up, sort of like this rainbow I tried to draw in your packet, but it should be symmetrical. It goes up, hits a high point, and then comes back down symmetrically. If we drew a line, that should fold together perfectly. The two sides fold together. So this is a downward parabola, and then as a smile, we can have an upward parabola. But so we have downward and upward parabolas, but they're U-shaped, and again, they should be symmetrical with some vertex spot, lowest spot, or highest spot that they can fold between and be symmetrical. So anyway, all objects in our world, by the physics of our world, follow this parabolic curve. So everything that's thrown up or propelled, we'll say, has to fall in this downward curve. Makes more sense for our discussion right now. We'll come back to upward curves later, but for this lesson now, they're all going to be these downward curves. And this curve can be defined as negative 16t squared plus velocity times t plus initial height. And so all objects in space in our world follow this curve, this formula. So this will always be given to you in the problem. The initial velocity, how hard something's thrown, is velocity, and then initial height, S sub 0, we call that. Sub 0 means the initial, or how high it was when it was initially let go from the hand, how far up, like Mia and her kite was 5 feet up. So the initial height of the object before it's thrown. Could be on top of a mountain, could be a higher number, but this is the initial projected height. V sub 0, the initial, how hard it's thrown or projected, and then T is the time in seconds, how long in seconds that it's in space, and S is how high it gets over time. The negative 16 is there for the pull of gravity, always pulling it down. All right, we're going to come back to that in the next video, so hang on just a minute.